So today's session on LabVIEW, then Modulation Toolkit and USRP is a basic introductory sort of session because I've already organized one session on GNU Radio and LabVIEW on 18th and 19th. So you all will be having a GNU Radio session on 18th and on 19th LabVIEW session with starting from the basics, then Modulation Toolkit, and the vendor will be covering. The BER the measurements basically related to communication like BER and SNR and the constellation graph. So whatever is basically required for your assignment completion and even further for your projects will be covered in that particular session. So considering that you all people basically are very new to LabVIEW, so I will start with LabVIEW with some basics, and I will be doing the coding part on LabVIEW, right? So then some introduction to MATLAB, no, not to MATLAB, modulation toolkit, and then USRP. So I have prepared one a video, a basic demonstration video where we have USRPs and how programming is being done. So how we are basically programming the USRPs, what is USRP, that will be covered first, and how we are programming a USRP and how the total communication is happening. So that will be there in the video, which will be I will be showing in the last. So let's start with LabVIEW. So before that, I would like to introduce myself. I'm Kagin Joshi, Assistant Manager, EC Labs, and so I'm basically working on USRPs and LabVIEW, and also we're assisting you people in your projects and all. I'm also pursuing my PhD from the same institute. So is my screen visible?
Yes, sir.
Okay. So what is LabVIEW? So LabVIEW basically, as you can see the name, LabVIEW. So it's Laboratory Virtual Instrumentation Engineering Workbench. So the word virtual instrumentation is basically signifying that we can design different virtual instruments which are not real. So we can design those instruments there on this particular platform. So let's see what is how a basic instrument looks like, right? So this is a DSO, which is there in our labs. So it's digital storage oscilloscope. So this is the particular model number which we have. So what all is visible there on the screen? Can anybody tell? Basically related to the DSO picture, this one,
Sine wave.
a sine wave. So basically a front panel is there with a scope or a graphical representation of whatever we are basically feeding. So in this picture, nothing has been fed. So it is we can consider a saved waveform which is there on the screen. Then it has some rotating knobs which you can see here. Some push buttons are there, right? Some feeding points are there. These are the BNC connectors, right? Some USB port are also there. So what I can conclude is a basic instrument consists of a front panel, and that particular front panel consists of some knobs, rotating knobs, some LEDs, which you can see, right? A display is there and some feeding points are there. So all these all the inputs we can call it as controls. So these all are controlling the fed input, these rotating knobs, buttons, right? And this display and LEDs are indicators, right? So a front panel comprises of indicators, controls, right? The second is the internal circuitry. So that is not basically visible to the user, right? So it consists of wirings, it consists of may consist of some counters, timers, which are basically not visible there on the screen, some DAC, right? Some PCBs. So everything which is hidden is which is not visible. So in terms of LabVIEW, we call it as block diagram, right? So here you can see a front panel comprises of a control palette, right? It also, so I would like to open the LabVIEW first, so it will be more clear. So this is the 2019 version which I have on my system. So I will just open a new VI. VI stands for virtual instrument, right? So whenever you will open LabVIEW, so these two windows will come in front of you. So first is the front panel and the second is the block diagram. By pressing Control T, you'll get a tile view where on the left side you have a front panel, on the right side you have a block diagram, right? So this is a shortcut, Control T. You'll be able to see both the windows, right? So now, as I just told you, that a instrument consists of a front panel and there is some hidden circuitry which is not visible to the user. So similarly on LabVIEW, as we are designing a virtual instrument, right? So we have a front panel, right? As I told you, on the front panel, we have a control palette and different sort of blocks are available. So as you already know about text programming, so you have done C programming, then Java programming. So there, text programming is used. But on LabVIEW, we have graphical programming. So it is just like whatever, you just need to select a particular block and you need to drop it there on the respective window, right? So whatever you see there on the control palette, so you just need to right click there on the particular window. Suppose I am on there on the block diagram. I'll just right click there and a function palette will be in front of me, right? So on front panel, we have a control palette. On the block diagram, we have a function palette. So all the functions, so the function is basically hidden. So these are not visible to the user, right? So those all functions will be there on the block diagram. So you can consider block diagram as the internal circuitry, which is hidden. Front panel, we have everything which is basically visible to the user will be there on the front panel, right? So this is about LabVIEW. Then it's not like that whatever, if one knob is there, suppose this rotating knob is there, so it is somewhere connected internally to some circuit that is not visible, right? So similarly, if I talk about LabVIEW, so whenever we are dropping any sort of control there on, or something from the control palette there on the front panel, you'll see a respective node already gets automatically created there on the block diagram, right? So whatever you are basically coding, so it will be linked, right? But there are a few functions, like some functions which you will be dropping there on the block diagram. It won't be visible there on the front panel, right? So we'll start with a basic small code, right? And we'll see how this works. So till now, any difficulty in understanding what is LabVIEW and what is front panel and block diagram? Anybody? So you can use the chat window if you don't want to unmute yourself. So if till now it is clear that what is LabVIEW, why we are using LabVIEW, how to use a LabVIEW. Am I audible?
Yes, yes.
So why people are not replying? So in that case, we can move forward, right?
Yes.
Okay, Harshit. So what about others?
Yes, sir.
Yes, sir.
Okay, so this is a front panel, this is a block diagram. We'll start with a simple addition and we'll see how it works, right? Now, suppose you want to add two different numbers. So we'll go to control. We'll click on numeric. If it is a Boolean sort of function, if you want to use a add or XOR, in that case, Boolean controls you have to use, right? So before starting with the example, let's explore what all functions are there, right? So on controls, you can see, you just need to hover the cursor over the option and all the respective sub blocks will get visible. So suppose in numeric, you can see numeric control, numeric indicator, right? So different type of this control and indicators will be present in this particular main block in numeric, right? And if I talk about the Boolean, you'll see different push buttons. So you might have uh, in your digital circuits or in your during your undergraduation, you might have done some practicals on digital in your digital design related courses where toggle switches, push buttons were used, right? So these are generally used to provide a on-off sort of input. So that will be under Boolean. So whenever you want to go for any Boolean operation, you can use go for a push button, right? So different type of sliders and toggle switches are available, right? So this different type of indicators are also available. If you want to go for with a round LED or square LED, you can go for it, right? So similarly, string related front panel controls and indicators you'll find in this string and path, and the others you can explore. So for array in data containers, you will see that, right? Similarly, in functions, if you want to go for any looping or some loops, some structures, right? So here you can see a math script node as well. So this particular node is used you know where you want to basically go for MATLAB related interface where you can mention something there on the MATLAB interface. This some MATLAB code will be there, some inputs will be provided, and the output you can see there on the LabVIEW. So it is this LabVIEW provides you benefit of get merging two different platforms, right? So as we are just discussing about LabVIEW, so the basics, if you want to hard code anything, you can use LabVIEW. For that other kits, other modulation, any sort of toolkit will not be required. But LabVIEW provides you a facility where if you want to design a communication related example or assignment or a sort of code, right? So in that case, you have to download modulation toolkit, right? So first you have to download LabVIEW, then modulation toolkit. So when you download modulation toolkit, this RF communication function will be visible. So if you have not downloaded modulation toolkit, this RF communication won't be visible, right? So in function palette, at the bottom, you'll be able to see this RF communication, right? So in this, we have modulation. If you want to go for a digital communication system or analog communication system, accordingly, you have to decide the modulation, right? So suppose in digital modulation, right? So these are the different functions which you have to basically use to design a modulation or sort of a code, a communication related code, right? So you need to open the session, then property nodes are there. Then at the end, you have to close the session. If you want to go for modulation, different sort of modulations blocks are already there, right? You just need to drag and drop a particular function there on the block diagram. You won't be able to drop it on the front panel. So the functions will get dropped only on the block diagram. So to know more about any particular block, you can just press Control H and just hover the cursor over it. You'll be able to see what are the inputs, what are the outputs of that particular block, right? You can see that some input bit stream need to be fed to this particular block. Some parameters need to be initialized or mentioned before. So that particular thing need to be provided as an input, right? Symbol rate, everything. So whatever basic things are mentioned there on the input, you have to provide them, and accordingly output complex waveform will get generated, right? So Control H, the shortcuts, you just need to remember. Control T, you can just tile representation of the front panel and the block diagram, right? By Control E, suppose have this block diagram in front of us. By Control E, you'll be able to see the block diagram, respective block diagram, right? So it won't be in a tile representation, right? The moment you click on it, so you'll be able to see the block diagram, right? So I will go with Control T right now. So this was related to the palette. So you need to explore. See, LabVIEW is something which cannot be completed in a 2-hour session. And in this, I have to introduce you to the modulation toolkit example, right? And to USRP related stuff. So definitely. at this 2 hour is not enough, but we have a main session there on 19th, where so by attending this session, you will be able to note down the points which you can ask, or you can explore in this duration from today to 19th. You can explore this lab view, and whatever doubts you have, you can ask on that duration. So it's a 5 hour session, so definitely you get time there, right? So let's start with a simple coding where we'll add two different numbers, and one indicator we'll be using to represent it, right? So we'll go with a numeric control. We'll place it there on the front panel. The moment you place it, a respective node will get created there on the block diagram. We'll take another numeric. So you can just follow the same numeric and numeric control. You can press it here, right? Or else what you can do, just select this particular numeric, press control and drag it. So this way it will get automatically copied, right? So for now we need only two inputs. You can rename this as well. Suppose this is input 1. So the moment when it gets black after multiple clicks, so that is the time when you can start writing. This is input 2, right? So what we need, so what is our basic task?
Sir, we need to check what will be the inputs and outputs.
So we have to basically add, right? So we have to add these two inputs, 1 and 2, and we need to see what is the output, right? So what we'll be needing, we have the input right now. So what
Adder,
all extra we'll be needing?
summer or adder.
So we'll go to the function palette. So that particular part won't be visible there on the control. It will be visible there on the function. In functions, we have this numeric controls, numeric functions. So there you can see add, subtract, multiply, divide. So we are planning to add. So we'll drop it here. Okay. I've already told you control H. Just hover the cursor over it. You'll see that it has X and Y as input, and the respective output is X plus Y. Now, what you can see there on the context hill, that X and Y are in bold letters. So why it is in bold letters? So what is the basic significance of mentioning it in a bold letters is that these are the mandatory inputs you have to provide. So you can see that till the time the code is not complete, or if there is any error, this arrow which we'll be using to run the code is broken. The moment you'll click on it, you will see all the sort of the errors which are there in your code. It contains unwired or bad terminal, right? Why? Because till now we have not wired these inputs. These are the mandatory inputs, right? So suppose now we have on control H, we can see that this is having two inputs and the output is X plus Y, but X plus Y is not bold. Let's see that if you are not connecting anything to X plus Y, will this error get removed or not? It gets removed, right? So X plus Y is not a mandatory thing which you have to mention. So suppose if there are different blocks in your code, at that time, all the block letter inputs need to be mentioned. If you're not mentioning it, error will be there in your code, and it will be a broken arrow and you won't be able to run it, right? I can run it right now, but I want to see the output. For that, I need an indicator. So just now, what I did, I went to the front panel. I created an input using this input control. Again, I mentioned a second input. So by pressing control and dragging it, or you can just go to the same option and you can select, right? So this way, we have placed two inputs there on the front panel. But how to place an output? So for that, two procedures are there. You can follow anyone. So in numeric, you can see the numeric indicator. Just press it and drag it, right? Drag and place. So this is your output, and it is basically sum. The moment you place this indicator there on the front panel, a node is there on the block diagram. Just connect it. So for connecting the wires and all, you don't need to select anything extra. The moment you will just hover the cursor over the option, you will be able to see this sort of wire bundle, which you can just click on that node and drag it to a particular node which you want to connect. Right. So this way, now the code is ready. Now suppose before running it, I will show you the second procedure to mention the inputs. Right. So you can just delete the selected whatever you want to delete you by selecting that particular uh, portion. So this way, now some broken wires are there on the screen. The third shortcut is Control B. The moment you will press Control B, all the bad wires, or I can say all the broken wires, will get removed. Right. Now, the second way to mention the input and output is by right clicking on it and create an indicator. So you can just hover the cursor over the point. So here I need an indicator because I want to represent a output here. So click and create an indicator. For input, create a control. Create a control. Right. So this way we have something. We have just placed the function and right click. We have this. We just when we placed the indicator and control, automatically, as we can see there, that it has been represented by x, y, and x plus y. So automatically the same we can see here, right? X plus y and y. So till now, any doubt? I think it's very easy. So even if you have any doubt, you can ask. How to use a control indicator. So these are very basics which I'm telling you. So it will help you a lot, definitely, to understand the 19th September session. So at that time, you'll be aware about LabVIEW. So this is X plus Y, a reverse process I have followed, indicator and mentioning the controls. But you have seen something by the name constant, right? Create a constant, right? So control, I've already told. Something we need to, something we need to mention there on the front panel to control uh, the the signal, right? And indicator is to represent the output. So what is this constant? Let me tell you what is this constant. Suppose I want something which, so whenever I'm using this create constant, I can use this as an input, but it won't get reflected there on the front panel, right? So suppose 7 I have mentioned. Right, so now I have only one input x. We are getting x plus y, right? But the second input I have mentioned as constant, right? So it won't be there. So we have no control on the on the second input, as it is in the block diagram. So the user who is basically using the front panel won't be able to control it. So it is mentioned there somewhere inside the instrument, right? So now let's run this. So for continuous execution, one time execution. So suppose I run the, so that is not visible. So I'm running it for continuous. So you can see currently I have mentioned 0. The constant input I have provided is 7. So the sum we are getting is 7. We can change the input there during the running state. 6 plus the constant value 7, we are getting 13. Right. So this is a very basic of LabVIEW where you can use different functions. So accordingly, you can go for the Boolean expression where you want to and or XOR not. So whatever function you want to use. So that particular thing also you can create on LabVIEW. Now the second thing is how I can. So let's make one more multiplication sort of operation. So where I will be utilizing the mentioned inputs, and let's create a indicator here. So this is x cross y, right? So now this is something which is mentioned there in our code, right? We have an input x, constant 7, and this is which what we are two outputs we have. One is the addition, one is multiplication. Now suppose I want to use, I have, whenever a designer is working on a code, so it designs in different sub VIs, means different virtual instrument it creates. Then it design a sub VI. Basically, I will tell you how to design a sub VI. So that I can use this particular code somewhere with my main code, right? So to do that, what I will do, so on the right top you can see these two different blocks. So this is basically the pattern and this is the icon, right? I will right click over it. You can see the patterns, right? Now, as you know, we have one input and two output, right? So I can go with any of the block which I want to use. So I will see where we have three, right? So maybe this one, just mm, so this is just for an example. So you can still, let's, this is three, right? So I have selected a pattern of three, right? Now what I will do, I will select this input. I have selected this pattern and then the respective, just a minute. Uh, so it's better to work with mouse rather than going with the touchpad because the control is somewhat difficult sometimes. So now you can see that particular thing is in some other color. So earlier it was white, now it is an orange color. So what I am doing is I have selected a pattern. Now I am marking it, right? So the first I have marked with the input X. Now again, select the second one and just hold your mic over it, and this way you will be able to match this particular with this one. Now select accordingly the third one. So I have matched my input and output with the pattern I have selected. What is my second task? Double click on the diagram of some oscilloscope or something which you can see there on the screen, right top, and there you can edit your icon design, right? So let me show you how you have to do that. So suppose I want to basically, now what I have done, I have created a icon and connector for this particular VI, right? So this is, I have matched and I have created a VI. So next time, whenever you want to, there is an option to select a VI. So before that, what I have to do is I have to save this particular VI, right, by the name WSI, suppose, right? So now I just said that, whenever you want to, the how the programmers are working, they are creating sub VIs, and then in the main VI they are utilizing those created sub VIs, right? So how to add a sub VI which I have already created? So for that, you need to just go to the function block, right? And the block diagram, right click, go down. There we have select a VI option and select this created VI, right? Are you able to see? Hello?
Yes, sir.
So now just click over it and just hover your mic, this cursor over it. You will be able to see that yes, this is X, this is X plus Y, and this is as multiplication y, right? So there are example codes provided by NI, which I will be showcasing you there at the end. So different modulation toolkit examples are there, different NI USRP related examples are there, right? Already provided examples for different modulation schemes, right? So there, this sort of sub VIs you will be able to see, right? The moment, so I have used the same VI on my same created VI. So rather than going for it, let's go for a different VI. So this is my second VI by the name Untitled 3, right? So here I can add that particular VI, right? So before that, I will just close this, right? Now the only thing opened in front of me is my latest VI where I have added my created sub VI, right? So if you want to, so these type of VIs will be there on the example codes. So whenever you want to explore what is there inside that VI, double click on it. The moment you will double click on it, that particular VI will get open, which I have just, we all have worked over it, right? So this is the VI we have just created. So by double click on it, the details of that particular VI will be visible, right? You can press Control T. So the block diagram of that particular VI, sub VI will also be get visible. So these are sub VI. For this particular VI, it is a sub VI, right? So any doubt till now how to create a sub VI and how to add it there in your main code? So you can unmute yourself, else I have to check the chat window.
No, sir.
So see, these are very basics. You have to, at least if this is clear, it will be very helpful for you in the upcoming session, right? So this is, so you need to explore, like, number of different options are there, right? So suppose you are working on robotics, right? So you need to download the robotics toolkit. So different type of toolkits are provided by the National Instruments NI, right? So this LabVIEW is a product of NI, and different toolkits are there. If you want to, if you want a math script module, that MATLAB module, definitely for that MathScript RT module need to be downloaded, which I have already mentioned there the email, and I think Mansi might have shared with you. Then, if you want to go for the communication modulation toolkit and different other, if you want to work on the FPGA, right? Then FPGA toolkit is also there, right? So this way, different toolkits need to be downloaded after downloading LabVIEW. Now, if you want to work on USRP, the hardwares which are there in the lab, I will show you how that hardware looks like, right? So if you want to program that particular hardware using LabVIEW, you need USRP drivers, right? So that part I have not shared over email, and but that particular part you have to download when you want to work on USRPs. So see, in my system, I have downloaded that NI USRP. So in the instrument IO, so for function palette, then in the instrument IO, we have this instrument drivers, and all the installed drivers are available in this system. So here you can see NI USRP driver. Here you can see NI USRP RIO. So this is also a type of USRP, right? So USRP stands for Universal Software Defined Radio Peripherals, right? So whenever you're working on any particular, so suppose, so the conclusion of this particular the toolkit installation is whenever you want to program or access a particular hardware or instrument using LabVIEW. For that, you need the driver of that particular LabVIEW, that particular device to be installed, right? As I've just shown you, this other devices are also there. So all these devices we can control, right? So different blocks are there which will be utilized, and which will we have to mention there on the coding part if we want to communicate with that particular device, right? So let's go to the slides. So this particular part, the front panel and the block diagram, right? So we have covered icon connectors and sub VI. So this is clear. We have covered, right? So how to create a sub VI and all. So these are the different available shortcuts, right? So Control B to remove the floating wires, then Control E to switch between the front panel and the block diagram window. Control T to get a tile view of both the windows, right? Then Control H for help. So these are very helpful shortcuts. So Control H, definitely whatever sub VI which is there in a block, if you want to explore it, double click on it, the hard coded blocks will be there in front of you, right? And Control H, by Control H, you'll be able to see what all inputs you have to provide, what are the mandatory inputs, and what is the respective output of that particular block. So this is a different a digital IC trainer kit which I have designed there in the lab using LabVIEW. So a very basic a trainer kit where for the first year BTech students, where they can select a particular IC, and the moment they select the IC, that pin diagram of that particular IC will be there in front of them, and the respective controls will be there. So by toggling this input switches, they can see the respective output, and the function table or the truth table will be there in front of them whenever they are selecting. So different gates, OR gate, AND gate, and flip flops have been mentioned in this option, this particular where they can select that particular option, and the truth table pin diagram will be there in front of them. So some instructions that you can always write there on the front panel. So suppose you have designed a code, and you want to write your name and this, so just click over it and you can write down, right, name, the roll number, whatever you want to mention, right? Other parts, definitely there is a lot of things and options which are need to be explored. So suppose different graph are there. So the moment you select this particular graph, right, so you will get a node there, a block automatically created there on at the uh, block diagram, right? So just need to see, need to connect this to the desired input output and the waveform, and the nature of the basically the waveform or the signal will be there in front of you, and that particular thing will be visible there in terms of amplitude time, right? So if you want to work in RF communication, right, and you don't want to go for the USRP related or hardware related programming, there just LabVIEW and Modulation toolkit is enough. And when it is about programming a USRP, a hardware, right? So for that, you need to have these NI USRP drivers. Then the hardware definitely and its accessories, right? So I have already uh, presented this, that how if the modulation toolkit is installed, definitely this RF communication option must be should be there in your block diagram. There modulation you can select, and whatever modulation code you want to design, accordingly you have to select that particular block. So this is NI USRP hardware and accessories. So what all accessories you will be needing while working on NI USRP. So you can see this is a USRP, USRP 2920. Am I audible?
Yes, sir.
Okay. So NI USRP hardware and accessories. So here you can see this is a front panel of the USRP, right? So there are TX and RX ports. So here you have to connect the antenna, right? Then some reference in and PPS in is required. So these particular ports are utilized. So just a minute. Me. So these 2 points, reference in and PPS in, are basically needed when you want to synchronize different devices or different USRPs. So suppose there are 4 USRPs and you want to synchronize both the USRPs so that synchronization is basically required in MIMO type of setup where different transmitters are they are transmitting at the same time and working on the same clock frequency. So to basically synchronize them, we need to provide input to these 2 ports, right? So we have a device by the name octo clock, right? So that particular device can provide the reference in and PPS in signal to around 8 such USRPs, right? So it has those many ports available with it, right? So for synchronization purpose, we are using octo clock, and that output of that octo clock is connected to the reference in PPS in of this particular device. But the second process which we generally follow is uh, there are USRP Rio devices which are capable of providing you the output reference in and PPS out. So the output of that particular device is connected to the PPS in of the second, and this way also the synchronization is being done, right? So in these ports, we are basically connecting the antenna. So here you can see RX1 and RX2. So two different receivers are there, and TX1. So we have only one transmitter ports. So suppose you want to transmit, right? So we have a definitely you have to design a transmitter code separately and a receiver code separately. So whenever you want to design a transmitter code, in that case you have to basically and connect the transmitter USRP with the antenna will be connected to the TX port, right? And the USRP which you are basically using for receiver, there you can connect to any one of the port, right? So definitely 2 different USRPs will also be required, right, to create such setup, right? So Ethernet port, this is connected to the host PC via LAN cable, right? So whatever coding you are doing will be on LabVIEW, right? When you want to interact with USRP, what all toolkits you will be needing? Anybody? So what all toolkits will be required if I want to access this USRP or want to program this USRP?
So Ethernet cable,
You mean the drivers and
drivers.
Right. So first is, as you said, Ethernet cable. So definitely media will be required. So here we are using Ethernet cable. So one end will be connected to this port and the second end will be to the laptop, right? So we need a laptop with a Ethernet port. And as said, USRP drivers. So definitely, as I've just mentioned, these all drivers will be required. And when you have that particular driver, so you'll be able to see in the instrument drivers that NI-USRP blocks. So in the instrument IO, this is instrument driver, and here you can see the NI-USRP RX. So when you are working on a RX code, these all things will be required. When you're working on a TX code, these all things will be required. So when I will show you the the example codes of the NI-USRP TX and NI-USRP RX, so at that time you'll see these all blocks there in the code. So what? Yes, Arshid.
So the diagram that you have shown, in
Mhm.
that there is one port for TX and RX.
Right.
So if we connect a single antenna, so from that itself at the same time it can transmit and receive.
So see, this is, you can consider this as a dummy device, right? It has a motherboard at the bottom where you can see this all ports are connected, and over the motherboard we have this RF daughter board, which is basically having these RF ports, right? Now we have to tell this particular device whether you want to, you're working as a TX or a RX. For that, everything need to be mentioned there on the lab view. So we have to define a port by the name. If it is a transmitter code, we have to define TX1 there, right? So this device will automatically understand that yes, this particular port is being programmed, right? So simultaneously, you cannot use this RX1 and TX1, RX1 and RX2 port, because there is this switch which is there inside it. Basically, when you are using RX2, so at that time, that switch will be on RX2. So the signal will be received from RX2 only. So it won't be received from RX1. So I will be discussing about the architecture of SDR. So there it will be more clear.
Okay, sir.
Okay, so antennas, these type of antennas are there. So they are working on different frequency bands. So this 2450, you just need to write down this over Google and you will be able to see. So even uh, on our website, EC Labs website in Shannon Lab, so I have shared the inventory this list where these are antennas are also mentioned, and you can just explore the frequency range. So, see, whenever we are creating any sort of communication setup, so we need to first decide what is the frequency we are targeting, right? And accordingly, we have to select the devices, right? So this particular 2920 model, it supports from 50 megahertz to 2.2 gigahertz. So if our application is outside this, definitely we can't use this. So definitely we have to go for a different device or a different USRP. Right. So this is for feeding. So we have adapter. Just connect the adapter. So some it will take some time to boot, and these LED will be sequentially. We'll see some changes in these LEDs. AB is from A to F, right? And there is a MIMO port. So different cables. A MIMO cable is there, which comes with the set. And while we are purchasing it, and you can use this to create a MIMO sort of setup, right? So if two transmitters are there, if you want to synchronize those, so you can use, you can go with the MIMO cable as well, right? So now, so is the flow clear that how this is basically working? So whatever coding you are doing it on LabVIEW, right? So the baseband signal will be fed to the USRP through this cable, and the rest function will be done by the USRP. So it has power amplifier. So everything is mentioned there in the architecture, which is the next slide. And accordingly, the transmission will be happening. And on the receiver side, again, we'll have a USRP, a cable, and a LabVIEW installed laptop, right? So their receiver code will be running. So that in the receiver code will mention the ports from where this USRP will receive, and accordingly everything will happen. So these are some attenuators also come with the USRP, which you can connect to the port, and then you can connect the antenna. So this way you can attenuate the signal, receiving signal, right? Then these three are the antennas. This is a tri-band antenna. This is these are two dual band antennas by the name VRT 2450 and VRT 90. These are SMA cables. So when you are working on a wired communication system where the transmitter and the receiver are connected with a wire, so these type of cables which we are using. So it has the SMA ports. One end of this cable will be connected to the transmitter, and the second end will be connected to the receiver port of that particular receiving setup USRP, right? So it will be more clear in the video, which I'll show you in the last. So as I've just told you, so here the only difference you'll see is it is research. So that is NI, National Instrument. This is ETIS, right? So these NI is a parent company of ETIS, and basically what it is do is it provides you a flexibility to purchase a particular device in segments. Like suppose uh, if I am purchasing a USRP from you, so this is something which is not required, but this is extra information I'm providing, that whenever you want to go for a NISRP, when you are going for a NISRP purchase, at that time that RF daughter board and everything. So this device, you will purchase this particular device with a fixed frequency daughter board, right? So the whatever is mentioned from 50 megahertz to 2.2 gigahertz is because of the daughter board which we have fixed over the motherboard of this device, right? So in ATIS, you can purchase the motherboard separately, and as per your need, you can purchase the respective daughter board, right? So it provides you flexibility to purchase the daughter board as per your application. But here, if you want to work on a particular application, you cannot purchase a daughter board separately. You have to purchase the whole device. NI provides you a support for LabVIEW. ATIS won't be providing you a support for LabVIEW. Still, you can program a ATIS Research USRP with LabVIEW by doing so, but you won't be getting a support for LabVIEW in that case. And secondly, there are other softwares like GNU Radio, right? So that particular software you can use to program a USRP. So you can use you program a USRP using GNU Radio as well, right? There you will be needing different toolkits to be downloaded before working on a GNU Radio with USRP, right? So here we have to just focus on LabVIEW. So this is architecture of the USRP, right? So here you can see the CPU GPP is basically, you know, our host PC. So what is the advantage is that everything like the processing part is being taken care by the host PC. So if you have a good configuration system, because everything, so the signal is modulated, whatever you know, different sort of uh, uh, conversions, whatever you want to do, that part will be taken care by LabVIEW, right? So by basically the LabVIEW is installed in the host PC, so a good configuration system will help you a lot in code, then coding, right, and running a program in a faster way, right? So all the processing part is taken care by the host PC. Then the data is fed to the this USRP through a Ethernet cable, right? So there on the USRP you have FPGA, right? Then secondly, uh, just a minute, I was planning to tell you something more. And so for programming this, this FPGA is there, but in some USRPs, they have a processor, right? So uh, this they're basically standalone type of devices where, you know, if suppose you don't need a host PC, so it is not every time feasible to keep that particular system connected with a USRP. So suppose you need a independent sort of system, there different USRPs are there which comes with a processor, right? And by you just need to configure the SD card and put it there in the USRP, and in that case you won't be needing a host PC every time connected, right? So in the applications like where UAVs are used, right? So there we cannot keep the laptop over USRP, and because the moment you disconnect this Ethernet port, right, this Ethernet port from the USRP, means if you disconnect any of the port, because the continuous communication is always needed. The moment you disconnect this, the error will get thrown and your code will stop then and there, right? So for those type of scenarios, we need a standalone type of device, and those are also available with ATIS and NI. So according to application, the USRP is used, right? So in our labs, we have NISRP 2920, 2921, right? And we have RIOs as well, but that are not a part of lab inventory. It comes under the project resources, right? So this is basically the, the architecture. So whenever you know, something is being received, right? So here you can see a RF switch. So this is for the receiver, right? So whenever suppose this RX2 is being used, at that time the switch will be here, it will be open and it will be like closed, so this port will work, right? So at the input we have the RX input, we have a low noise amplifier, right? So here you can see that only the TX signal will go through this. Whenever it is receiving, it will come from this particular channel, right? When RX is working, this channel. When RX2 is working, it will be connected and this will be disconnected, and this particular point will work. So every time whenever the USRP is receiving, this channel will be followed, this particular channel, where it will get passed to a low noise amplifier. Then there are different type of amplifiers, then mixer, right? So this power amplifiers and low noise amplifiers, these are basically available there on the daughter board, right? And other things like the ADCs, DAC, right? So this everything is basically there. The filters are there in the at the bottom in the motherboard. So Ethernet port, everything will be there on the motherboard, right? So we have this mixer. So whatever signal we are it's being received, it is passed through the mixers. So this is basically which you have already read in your communication system, that these the architecture. So the same architecture is being followed while for designing a USRP. So suppose a signal is being transmitted, this receiver port, and we have connected the antenna to RX2, right? So this particular port will be working. The moment we have connected it to RX1, right? So this switch is basically connected to RX2, and the signal will come from here to this, will pass through the noise amplifier, will follow this particular process, and at the last we'll get, after this DDC down conversion, we'll get the baseband signal. So this is a high frequency signal, because every time whenever we are transmitting a signal, we have a power amplifier, or basically this transmit amplifier which is there. And the so basically after this conversion, till this time we have a baseband signal. After this we have a high frequency signal, right? So that particular digital signal which is being fed from the host PC is fed to this USRP, then it is up converted, then digital to analog conversion is there, because ultimately the signal which we are transmitting will be in the, analog, right? Then we have a low pass filter, right? Then so this is basically, this filter decides the bandwidth of the USRP, right? So if what is it, the 20 megahertz USRP bandwidth, whether, because different USRPs are there with more bandwidth, so accordingly you have to decide a particular USRP as per your application. So this is what is basically followed: baseband signal up converted into analog, low pass filter, pass through mixer, amplified, and transmitted. Now the second USRP, it will receive low noise amplifier, mixer, right? Then analog is converted into digital, then down converted, and after this we'll have the baseband signal which will be able to see there on the via Ethernet cable. It will get fed to the LabVIEW platform, and there we'll be able to see that particular signal. Right. So this is the internal circuitry of the NISRP. Yes, Harshit.
Sir, I have a small doubt. So
Mhm.
you use the word daughter board. So what is daughter board?
So basically, the daughter board is when to so it is just to differentiate it from the main board. So this is the bottom one, right, where this particular small board has been fixed, is the motherboard, right? And the RF board which we are fixing over it, so it has some slots, and we are just fixing this particular daughter board. So this is which I am calling as a daughter board. So it is a, so whatever frequency and whatever RF term which we are using is because of this particular board. So it is deciding to what frequency it will work. It will decide the bandwidth of this particular device. So everything will be decided by this particular board which has been fixed over the motherboard. So this is the daughter board, RF daughter board.
Okay, sir.
Okay. So till now, it's like, is it like like clear? So what is lab view? What is front panel? What is block diagram? Where we get the functions, right? Where we get the controls, and how to program a USRP? Is it clear?
Yes, sir.
So see, on 19th, right? On 19th, will be there will be, it will be like a hands-on session. So just be ready with your modulation toolkit installed, then the MathScript RT module, right, installed. So, and with your doubts as well. So till that time, you can explore this software, right? At least with the basics of LabVIEW, if you have, a good idea of the basics. So definitely, there won't be any need of modulation toolkit because you know better about the blocks, right? So you can hard code it. So you can start from a basic block. So just like uh, amplitude modulation block is there. So I will just go with example code, right? So how to find a example, we'll see. So whenever you are done with your modulation toolkit installation, just see whether you are able to see the examples. You can find the examples there in the help. We have this find examples, right? So just you need to click on the find examples. So, and then these are the examples which are available, right? So you can just in the toolkits you'll find this modulation toolkit, right? Then these are the basic things which are available with you. These are the codes which are available with you. You can, directly access any code. So these have been provided by NI for your understanding and to save your work. Means you can start from example and then you can, that will take less time as compared to hard coded. So this is a example of a PSK transmitter, right? So you have to, I think, download the NIUSRP toolkit as well to access these examples. So I will share the code. I will share the link of the NIUSRP driver as well after this with Mansi, and she'll share with you. So now here you can see. Let's talk about this. Right. So here, are you able to see some sub VIs that has been used? Like this is a PN sequence. Now this is also VI that has been created. The moment I want to, basically I want to know about this particular VI, for that I have double clicked on it. Now I have a different VI with me. So this is I'm telling so that you can explore a particular VI in a more better way. So if you have any doubt related to VI, just double click on it. Now this is basically what is there in that particular VI, which is there in the main program, right? Again, in this particular VI, there are number of sub VI. So definitely, they have provided you a lot. Like you can directly run a particular example to test a particular code, right? So now here you can see. Now, if I want to check what is there in this, I will first press Control H, right? It is empty generate filter coefficients, right? So these all these all subblocks which you are basically seeing, will you'll get it where in the. So see, I'm not able to add anything there because this is something example is there and I'm not able to. I can't edit this, right? So but I can explore it. So this was basically for generating the filter coefficients, right? Right. This is the case structure, right? So see, whenever you are working on USRP, at that time you'll be needing these extra blocks like NI USRP, right? So this is NISRP configuration signal. Then this is the TX open TX session, right? With the open TX, you can see the device name. So here you have to add a control, and that particular control will you have to mention the IP address of the device, the USRP. So whenever you are working on a USRP, at that time you have to add these extra block at the top, right? And when you are not working on USRP, what you will do at the time, you definitely you have to design a sort of transceiver code, because see, whatever you are whatever is getting generated from a transmitter code, right, need to be received by a receiver code. So definitely in a simulation code, you have to use a connected sort of communication, right, in modulation, in a simulation code where no USRP driver is available. So this is TX. So after this, whatever you are getting at the output, this is the main data which will come from the TX code, right? And this is fed to a USRP block for writing. So you are writing the data which is coming out of this particular block which is on USRP, and you want this to be written to be basically transmitted, right? So for that, what you have to do, you have to feed these particular signal to this USRP TX data. So any TX code which you will open, you will find this sort of structure where you have a modulation toolkit code at the bottom, right? And just to communicate with the USRP, you will be just feeding. Suppose I want to transmit this data, so definitely to the TX to the TX right, right, we have to feed that data. In receiver, I will just show you that where we are feeding or from where we are getting the data. So it is just like here we are mentioning the the channel, right? So this is basically, so where is this active antenna is connected? So see what is happening. I will start again, right? So this is NISRP TX. You have to use this. You have to use this particular property node, then this configuration signal, and this write TX data in a while loop, right? So with the configuration signal, you can see we have to mention the active antenna, right? So which antenna is being has been connected, right? So if there are two TX port, or in the receiver case, we have to mention RX1 or RX2, right? So by clicking on any of the front panel node, by double click on it, you will be able to see where that particular block has been placed in the block diagram, right? So need to configure, you have to place this here only. You cannot place this after this, right? So open TX, then you have to configure it, then this write TX data, and then at the end, you have to close the session. So when you are working on USRPs, definitely this is something which you have to add in your modulation simulation code, basically, right? So on 19th, this upper portion won't be there. Only the this lower portion will be there, because we don't need a USRP communication there. So whatever signal, so this is a case structure which you will be using to select different modulation schemes which have been mentioned here. So let me show you. So these are the different PSK formats that has been placed on the front panel, and you have using a case structure, we are selecting a particular format, and whatever parameters are being generated, that are fed to the next block, which is generate system parameter block, right? And which requires these all inputs. So PSK type, then samples per symbol. So see, these all particular inputs have already been generated in the previous session, in the had to be generated in advance, and need to be fed to this particular system parameter block. And after that, a block is there which has been designed by NI, and on double clicking you can basically explore what is happening inside. So when we are feeding the PSK parameters, right? So this is the PSK parameter which is being fed to this particular block, and the output which is coming out of it is a output complex waveform, right? So this is a complex waveform which will be basically transmitted from the LabVIEW or your host PC to the USRP. And what how it is being transferred, you can see that the connection is being made to the TX, right, TX data block of the USRP. The moment you are connecting this particular block, the data will be fed, right? So this is directly, this particular block is directly communicating with the USRP, right? So you have mentioned the TX, the antenna port, everything you have mentioned, right? And you have to mention the IP address, and it will directly contact and communicate with the particular USRP connected, and will feed this particular generated data to the USRP. Now, if you want to explore the receiver part of this, so this is the receiver USRP, receiver VI for the same, right? And there you have to define the active antenna, right? Because there are two ports, so definitely you have to define the antenna. Then the IP address of this particular USRP, right, need to be defined. And then in the code, you can see that how the data is being received, right? So from the, so where our data is, you can just track, right? So whatever. So this is, these are the blocks which you have to use when you are going for a receiver code with USRP. You have to open RX session block you have to use, then property node, and then this is the configured signal NISRP block. Then this is NISRP initiate, then fetch RX. So from here, because on what is happening on the receiver side, that the signal is being received by the receiver antenna, and it is fed to, right, it is passed to a low noise amplifier, right, following the architecture of it, and at the end we get a baseband signal after down conversion, right? So this is the data which is coming from the USRP and is being fed to your laptop. This is the data, right? And to that data, what we are doing, this particular resampling block is being used, right? Then demodulated, so that data is demodulated. Then it is one, basically create, this is something which has been created by NI sub VI to for filter, right? Truncating filter has been basically used. And after that, we have this format constellation function which we have to use to see a constellation, right? To see a constellation there on the front, here on the front panel, what you have to use is, so in RF communication, you will find that constellation graph. So you can just place it there, right? So the moment you will place this, everything is like uh, very similar. Like you will be getting all these particular blocks. So this is what you can see. So the moment you are creating a constellation, dropping a constellation graph option or there on the front panel, you will get all these three blocks automatically added on the block diagram. So this is these three. So these three are basically linked to the constellation graph which is there on your front panel. Let me, so this is constellation graph which you are getting. The moment I right click on it, so I can see that what particular function is basically representing the constellation graph. For so there are bad wires, broken wires. I have deleted using Control B. See, the this particular portion will be taught you in the on 19th of September session, right? A 5 hour session where it will be like a hands-on session, right? So, but till that time, at least you can explore the examples, how the things are being done. You have a control H option. Then these all functions are available, right? In the structures, a case structure is there, right? So here, whatever have been used is a case structure. So this is a case structure, right? So different whatever blocks you want to add related to generating a coefficient, you can go for. These are the demodulation, modulation. In the utilities, you will find all the different blocks like the system parameters block, filter coefficient block, which have been used in the main code, right? So you can, if you want to generate different bit patterns, so everything will be basically have some block already mentioned. So this is for bit to symbol, right? Then symbol to bits, right? If you want to use a match filter, you can use this particular block, right? And by using control H, you can explore that particular block in a more better way. So my next question is like whether it will be difficult for you to at least explore. So you know how to explore a particular code and where it is basically available. Any doubt in this? So from where you will get the code and see LabVIEW is like
So
whatever.
could you please again show where these examples are?
So for examples, I think you have not downloaded the this USRP one, right? So these examples will
Um,
be visible with the USRP driver. So that toolkit you have to download. So whether it is downloaded or you have downloaded only modulation toolkit and MathScript RT module.
right now I haven't downloaded it.
Okay. So when you will download it, not so you just need to mention on the search window, just write down NI USRP, right? The moment you'll write NI hyphen even, then also this ESRP examples will come in front of you. Otherwise, you can write down NI ESRP. The second option to access the examples is through the LabVIEW window. Just you need to go to help, right? It can, and in that help, we have this find examples. So click on find examples in the help, and whatever toolkits and modules that has been installed, you will get all those examples here, right? So different toolkits are there in my system. So when that particular toolkit will get downloaded, so suppose Mathscape party module, so these are some VIs from where you can explore the Mathscape RT module related examples, right? And if it has been
Okay.
perfectly installed, you won't be facing any issue in running the code. It's a simulation code, right? So they might have used some Mathscape module. So here you can see. You can suppose you are good in MATLAB, so you can utilize some sort of script node here and need to mention the inputs which you are mentioning there in the editor, and the outputs will be as per the equations or functions you have which you have mentioned there on the MATLAB node. So here you can find that math script related blocks. So in mathematics, right? In mathematics, first click on mathematics. Then in mathematics, you have the script and formula. In script and formula, you'll find this math script and other different nodes. You need to explore it, and by just placing, you can by control H, you will be able to understand the block pattern. And for more detailed help, you can even just click on the question mark which is there on that option. So here, the moment you press control H, after control H there is a question mark. Click on that question mark, right? So that, so this is something which will be there in front of you, and some detailed information you can get from this particular window after double clicking. So it is, everything is mentioned. Use this node to execute your script. Enter your script, which you can contain built-in script functions and user-defined functions. So everything has been mentioned. So this is a way to basically you can learn more about the different blocks. Control H or the question mark you can place so to know it in a more better way, right? So different functions and different examples for the math script RT modules are also available. Definitely this particular session which I have just conducted is not enough to, for your assignments and all, and to basically for that we have this 19th September session, because as the vendor is there, and so definitely a 5 hour session will be more helpful for you people. But still that 5 hour session won't be helpful if you have a some idea about this LabVIEW. So during this time, at least explore about LabVIEW. Now you have a clear idea what is LabVIEW, where we can get different functions. If you're working specifically on uh, RF communication, then just go with the examples and the different blocks, right? You can even hard code this. Mm, by hard coding, I mean that see, whatever sub VI they have created is somewhere it is having, somewhere they have, even if it is a sub VI, but some basics of the LabVIEW coding have been used. So you can go with that particular function also. So just like following the equation of a modulation scheme. So if it is amplitude modulation, you know the equation of amplitude modulation, and accordingly you can define the different parameters, and you can use the functions like numerics, multiplication, addition, right? Whatever you need, and accordingly you can, by using the basic functions, you can hard code the main code, right? So in that case, you won't be needing the sub VIs, and everything will be more, more clear, right? See, in RF communication, if I go with uh, the amplitude analog modulation, this, right? This is MT modulate VI. So it is basically for amplitude modulation. We are using this particular VI. I will double click on it, right? So control T. So here you can see, right, message signal is there. They have defined a modulation index. Everything they have defined. They have used a case structure for error or no error. No need to. You can also skip this case structure, because considering that there won't be any error. But for checking the error, this type of case structure have been used, where if any error occurs, definitely this error out will be generated, or a dialog box will come in front of you, or some data will be there here after running it, right? So what is this? Basically the source of error, so that will also get displayed in front of you. So this is the basic advantage of using this error out uh, option, right? So see, this is already, this all is hard coded, right? So you can opt for the function you want to, the way you want, right? So you can hard code it, or you can go with the sub VIs that are already available, right? For accessing the available sub VIs, just follow the same. Everything is there. Property node, which we have just seen there in the one example, is also available, right? So just explore, and I think that will be more helpful for you people in on 19th, because at that time you will have more doubts to ask, right? So that particular person is will more expert on LabVIEW, so he can guide you in a more better way. And I have basically shared one agenda considering the pattern of your assignments, that what all basically things are there which need to be told. So that particular thing where we have to fetch a particular file, a different sort of image we can transmit, right? How to create a code for image transmission or audio transmission or different sort of BER calculation and SER calculation. So those particular things will be there on 19th. It will be more detailed sort of session, but at least from I consider that I hope that from today's session definitely things are clear, at least somewhat clear about the lab view, the modulation toolkit, how to access the functions, how to access the examples, and the USRP. So I have prepared one video for so I will share the link of that particular YouTube video, and that is our video. So just access this, and we can meet after 4 minutes. So just uh, take 5 minutes time. So it's 5 minutes 7 seconds. So you can take 5 minutes time to watch this video. So we'll have a discussion about this. So have you all seen that video? Hello.
Yes, sir.
So that is basically a simple setup of like how USRP is being programmed. So every time LabVIEW has to tell the USRP that yes, you have to work like a transmitter or receiver. So everything is being designed by LabVIEW. So LabVIEW is taking care of the processing and all, right? So that particular part, LabVIEW's responsibility is to receive a baseband signal or to provide a baseband signal based upon the code running on LabVIEW API, right? So different toolkits as per applications you can download. So that for that you can visit NI's website. So different toolkits are there, right? And you can even so just like I said that you can explore, like so I just told you to explore this in a more better way. So for that what you can do is you can a number of videos are there on YouTube where you can just see the functioning of the working of a simple block, right? So that particular part also you can do. I will also share some material with you people through Mansi, where some courses, some labs have been designed. So and detailed labs have been designed by some authors, and so that will also help you in understanding this. So ultimately it's about your interest and how much you want to explore this. So material is very enough. I will provide some material from my side. Then again on 19th you'll have a detailed session where more insights of LabVIEW will be there in front of you, and definitely mm, the basic agenda where the instructor will tell you to how to get the BER, then SNR and constellation, right? And it will be more helpful in understanding the different blocks of the modulation toolkit. So these all blocks will be explained. So if you have at least seen these blocks and you might have faced any sort of issue during this particular time from today to 19, so you can ask at that time, and definitely that will be more fruitful for you people rather than just again seeing opening LabVIEW on 19. So uh, I make basically request you all people to keep it hands on, right? If just download it, because till the time you'll not work on LabVIEW, definitely the blocks and everything, definitely that coding will be difficult for you people. So as we have an instructor, right? So definitely keep it hands on, and whenever you are facing any challenge, because the challenges can be many. It's not just related to the tool, maybe related to something which is happening with your system, right? You're not able to facing some issue related to installation, downloading, right? So if these type of issues are there, just let me know before 19th so that we can work on it, right? And on 19th it should be hands on. That will be more helpful for you people, right? So if for wireless, we need antennas, we need LAN cable, right? So LAN cable, host PC, and USRP is common for a wired or a wireless. But when wireless, definitely antennas comes into picture, and when it is wired, those SMA cables, the cables, each type of cables are used for wired, right? Then these are some important points which have already been mentioned there in the video, that desktop and USRP need to be in the same network. That means the IP address, because the USRP, when you have purchased it for the first time, definitely the new USRP comes with a IP of 192.168.10.342 or 1, right? So you have to either you can change the this IP address of this USRP. For that, as in the video, NI configuration utility has been mentioned. So there all the IPs will be there in front of you, and I think it's there in my system as well. So this also gets installed when you install the NISRP this driver, right? And here you will be, when any device is connected, the device ID or the IP of that particular device will get will be in front of you. Connection here, as you are using Ethernet, so Ethernet will be mentioned in USRP Rio's PCI Express cable. A different type of media is utilized or cable is being used. It can also be used there. So in Rios, we have a facility for NI USRP, this PCI Express cable. So at that time, PCI is written. So whatever connection media has been used, so that particular will be there mentioned here. Then the type, the model will be there, the USRP model, right? Then you can even change the IP address. So when a device is connected, it will show you the current IP and the IP you want to basically mention or you want to write, right? So this type of configuration utility window assures that device is connected, because that is the first thing, right? Otherwise, if it is not showing here, if you will run that code, error will be there in front of you, right? So now, just a minute. So this was the video. So from here you can see. So just check whether you are able to find the modulation examples at this particular point. So you just need to go to the National Instruments folder, and in the National Instruments folder, you'll find this LabVIEW 2021 or whatever version you have installed. Their examples you will be able to see in that modulation simulation examples, and in examples interactive. So these type of so all the examples you'll find there. And as we were seeing the NISRP uh, examples related to modulation, so that's why all the examples which were listed in the modulation were having those NISRP blocks in it, right? So this is a part to NISRP example. So I will share this with you all people. So no need to worry about it. But maybe while installation, whatever path you have selected, so just you need to check. So till National Instruments, you will be able to see. After National Instruments folder, just see where that LabVIEW is installed, and in that LabVIEW, you need to track the examples. I just find out where you get those examples, right? So this was basically for the modulation toolkit and USRP related codes. So so that's all for today's session. Let me stop the presentation. So that's all for today's session. So I hope that at least you are now aware about what all things you have to do, and maybe in this duration you can explore LabVIEW as well as the examples in a more better way, as now you have LabVIEW installed in your systems. So, like anything extra you want people basically you want to ask?
So I have one small doubt.
Uh,
While installing LabVIEW, it is asking for a license key.
right. So, see that whenever, so as this LabVIEW is a license, so definitely you need to purchase a license. So in our institute we have that license, right? So, but what you can do till for now, as one like 7 days trial version will be there. After that, you can extend it to 45 days, I think, right? For now, just do that particular part, and till that time I will configure few of our system where you can just remotely access those systems with a LabVIEW everything installed, and you can complete your work.
Okay.
Okay.
Okay, sir.
So but for 45, like if you, even if you want to like start today, 45 days will be enough for you people to at least explore this. And after this, definitely till that time I will uh, arrange something for you people, right?
Yeah, like if license version is there in Lab PC,
Mhm.
then by using the AnyDesk, We can
No, don't think about it. So there are different techniques by which you can access the system
yeah,
remotely.
remotely. Yeah.
Uh, so I will not be using NI's desk rather than providing you all people remote desktop access, and maybe you can on time slot basis you can access that particular system, right?
Yes.
So that part I will have a discussion with Mansi, and we'll check, we'll work upon it, right? So but the main thing is for 19th. So see, just check whether that modulation toolkit which you have installed and the Mathscape party module which you have installed is working fine or not. And the only way to check it is just open some examples and see whether any error is there, right? So just to see whether any error is occurring or not. If any error is there, this arrow will be broken,
Yes, sir.
right? So if there is no broken arrow, that means everything is fine. So that toolkit is properly installed. Now you can explore it, and definitely it will be helpful for you in during the hands-on session.
Okay, sir.
Okay.
So 19th is Sunday, so it will be on
19th
Sunday.
is Sunday, right? So the vendor is available on 19th. So as it is Sunday, so I believe you people all will also be there, right? And just explore LabVIEW, and at that time, you can basically take it as an interactive session where you can ask the whatever doubts you have during the session.
Okay, sir.
Okay. So I think not many people were there in the session. Only Akanksha, Dhanushi, Harshit, and Marine. So Sayed even left, right? So no issue. So I hope. So what about Akanksha, Dhanushi, and Marine? So
Yes, sir. So actually, I joined the session a little late. I was attending my TA shift session. So I will just follow through the recording of this meeting.
okay. And what about Dhanushi and Marine?
Yes, yes, I had followed the meeting, but I couldn't practice because I had the same issue of activation key, so I couldn't do it
Oh,
simultaneously.
okay, 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 okay. So
Yes, sir, me
at
too.
least you people got the idea about what to do and how to do, right?
Yes,
Yes,
sir.
So what is
Yes.
LabVIEW? Because this software is somewhat different from other software where you just need to open it and start the text programming, and it is like two different windows are there, right? So I hope that a little information I was able to transfer to you people about LabVIEW and about the modulation toolkit, and how a USRP is being used and being programmed via LabVIEW.
Yes, sir.
Yes.
Definitely, it will help us a lot because as a beginner, otherwise we would have to invest a lot of time to get such a basic understanding.
Right. So even if like I've taken it in a force session, would have, like people might have not been able to catch, because lots of things are there in LabVIEW, right? So a new software definitely needs time and more practice from your side. So just explore this videos and some material I will share through Mansi, and others like whatever you can access the NI website. Then you can you'll be able to see some YouTube videos as well. So that will also help you a lot.
Yes, sir. And sir,
Hmm.
kindly share this video also because we will take the
Ah,
reference from this video while practicing on hands-on practicing on LabVIEW.
no issue. So once I get this video gets processed, definitely I will share this also. Okay, and just practice, because ultimately and if you people want to practice on USRP, right? We will create a setup for you just like what was there in the video, where you will be having the access of both the systems, and you can run a transmitter code and you can run a receiver code. If you want to design your own code, you can run that also, and you can check what you are receiving there on the next end. So that will be a sort of, it will not be a simulation, it will be via USRP and a wireless sort of communication. So it will be more sort of learning and will be there more, and it will be more interesting, I think. So, okay, so let's so just uh, go for the 7 days and extend it to 45 days for now, and we'll work upon how we can provide you the lab systems access, and definitely time slots will be there because other courses are also running, and you can access the system, you can run the code, and you can work on that part also. Okay.
Okay, sir.
Okay, sir.
Okay, then uh, thanks.